What I want to do in this clip is go through the proof, a proof for the law of cosines. There's several proofs you can use. This is one that you can use, and basically to show the level of equation and algebraic manipulation that you are expected to know, be aware of, and be comfortable with at pre-cal level, college algebra, trigonometric level. As you go into calculus, you're just expected to be able to manipulate this and it work. Also, to help you understand the trigonometric identities that you need to be aware of and know, prove them out to yourself. We're going to do one of those, prove it that it really is true as we go through this. Proof of the law of cosines. What we're going to start with is we're going to start with triangle ABC. It is a non-right triangle. And what we're going to do is we're going to cut it with an altitude to create two right triangles. And when we create those two right triangles, then what we're going to do is we're going to use those right triangles and the trigonometric ratios of those two right triangles to create a rule by which we can solve for unknowns of non-right triangles. Again, we're taking tools that you've learned in the last 2 or 3 weeks, and we're now manipulating those tools to create more useful tools and generalize those tools so we can use them for all triangles, not just right triangles. So what we're going to do is we're going to drop that. The altitude we're going to call BD intersects AC at D. We're going to call that altitude H. We're going to call this little section that's created DC R. And then, of course, this just becomes B minus R. Notice that little b is across from the point B, little c is across from point C, and little a is across from point A. The labeling of your triangles is very, very important when using law of sines, law of cosines, so that you get things in the proper place and you understand how to set these up. Again, we're going to just play with trigonometric ratios. Wow, the sine of C. Let's look over here. What is the sine of C? Well, it's opposite over hypotenuse, which is h over a. Well, let's get h by itself. We're going to multiply both sides by a, so we have a sine of c equals h. Okay? Cosine of c equals adjacent over hypotenuse, so r over a. Now let's get r by itself, so a cosine of c equals r. We've set up some things now that we can use. Now, what we're going to do is use the right triangle ABD. Using that right triangle, we're going to solve for c using Pythagorean Theorem. That's all we're going to do. So all this is right here is Pythagorean Theorem. Using this triangle, well, what is the hypotenuse? It's c squared. What are the legs? Well, one of them is h. That's pretty easy, h squared. What's the other leg? Well, it's b minus r. Well, let's square it. You're going like, oh no, that looks like this. Yeah, it's going to get into a quadratic, isn't it? Yeah, it is. It gets better. Because what we're going to do is we want to use the trigonometric identities of those segments. Huh? Yeah, we want to use the trigonometric identities of those segments because when we do that, certain things happen that then we can generalize this equation and generalize Pythagorean Theorem to be used on all triangles. So the proof, ironic, the proof for the law of cosines starts with the Pythagorean Theorem and comes up with a modification to the Pythagorean Theorem that we can use for all triangles. So let's go. What's h? Well, over here we said h was what? A sine of c. So c squared equals, parentheses, a sine of c, close parentheses, squared. Leave it there. Well, what's b minus r? Well, we know what r is, so let's replace r with this. You're getting this more complicated, Coach Smith. Yeah, I am. It gets more complicated, and then it gets simpler, but not too simple. So b minus, what's r? A cosine of c. That entire quantity squared. Now let's extend it. Okay, let's do it. C squared equals a squared. We've got to do both sides. This is how we square a sine. Sine, we put it there. Don't put it at the end because it's not the sine of c squared. It's the sine squared of c. Is what we want. Okay, we want the sine of c squared, not the sine of the angle squared. So this is how we write that. This right here, well, from your good old, do it days, this is it. take the first item, square it. All we're doing is FOIL it. Wow, square the first one. Double the second one, take the sign, double it. 2ab cosine of c's. And then square the second one. Well, a squared, that negative is going to become positive. A squared times the cosine squared of c. Okay? We're going to manipulate this a little bit. I'm going to bring this piece right here up front so we can manipulate a little bit. So we have c squared equals a squared sine squared of c plus a squared cosine squared of c plus b squared minus 2ab cosine of c. We're going to undistribute that, and we have c squared equals a squared quantity sine squared of c plus cosine squared of c, close parenthesis, plus b squared minus 2ab cosine of c. Now, we're going to go over here and want to look at a trigonometric identity. We're going to take sine squared of c plus cosine squared of c. That equals 1. It's a known trigonometric identity. We'll prove it, Coach Smith. Okay, we're going to prove it. You do this with any angle, and you will prove it. Any angle. Well, he's using a special angle. Well, I'm not going to use a special angle like a 30-60-90 or a 45-45. Okay? What we're going to do is we're going to use 28 degrees. So we're going to take the sine of 28 degrees and we're going to square it. And then we're going to take the cosine of 28 degrees and we're going to square it. And it equals 1. So what is the sine of 28 degrees? It's 0.4695. Take it to 4 decimals. Squared plus the cosine of 28 degrees, which is 0.8829, and we're going to square it. Now when we square those, we get 0.2204 plus 0.7796. I think if you put those in your calculator and you add that quantity, you'll find that it equals 1. Guess what? This whole pile of stuff right here is 1. What's 1 times something? Something. So we got c squared equals a squared times 1 plus b squared minus 2ab cosine of c. And hence we end up with c squared equals a squared plus b squared minus 2ab cosine of c, which is the law of cosines based here for us to find this. Now, by doing similar manipulations and techniques and methods, we could find that for A and for B, do the same thing. Gives you a little hint, and look at the level of equation manipulation, algebraic manipulation that you are expected to be comfortable with when you go to college and you begin to take serious calc. Honors classes, we talked about some of those courses. You asked me, did y'all take physics in college? Yes, I took physics in college, 35 hours of physics in college. I have a BSE, which stands for Bachelor of Science in Engineering. I'm not a mechanical engineer or a civil engineer, but I have 36 hours of courses related to physics directly. All right? I have 30 hours of courses related to math, 15 hours in calculus and differential equations alone, 6 hours in stat probability, another 3 hours in linear algebra, another 3 hours in operations research, another 3 hours in economic analysis for engineers. On it goes. Okay? Also have another 3 hours in another course called error analysis in equations and computer programming. And on it goes. So, you know, the courses that you're taking in high school are nothing. They're just the very bare, very tip-top snowflake of the iceberg that you're going to experience when you get to college and you begin taking math. Well, I'm not going to be an engineer. I'm going to be a business major. Business has the same kind of math courses you need to take. They just have to do with business. You look at anything having to do with investments, Wall Street investments, business, analyzing a business, top, bottom, sideways, up, down, every which way. All those produce graphs. Graphs have slopes. Graphs have equations. They have functions and relationships. Doesn't matter if it's engineering or business or medical. The analysis of all those functions and patterns is math. And sooner or later, it's going to get into trigonometric ratios and trigonometric functions. Proof of the law of cosines.